Hello everyone, it's a pleasure meeting you all in my mathematics class. Today I am taking yet another distribution called the Gamma distribution, which is also a continuous distribution, and we say that a random variable is x is said to follow Gamma distribution. It is x alpha beta, where alpha and beta are the parameters. If probability density function of x is given by fx of x is equal to beta to the power of alpha divided by gamma of alpha into x to the power of alpha minus 1 into e to the power of minus beta of x greater than 0, alpha greater than 0 and b greater. See, this is a continuous, that is, we say that x is a random variable that follows the gamma distribution if its probability density function is given like this, and this alpha is the shape parameter. It is the shape parameter, and beta is the rate parameter, and alpha can take all the values e of x is equal to 0 to infinity of f of x dx. This f of x is nothing but our PDF of the gamma distribution. So this is equal to, this is equal to 0 to infinity. It is x into, it is beta to the power of alpha, gamma of alpha, into x to the power of alpha minus 1, e to the power of minus beta x into dx. So this is what we get. Now, so this can be written as, it is beta to the power of alpha divided by gamma of alpha into, within bracket, this integral of, it is x to the power of alpha, see x into x to the power of alpha minus 1, so x to the power of alpha into e to the power of minus beta x into dx. So this is what we get. Now, see, we have to evaluate this integral. Now, let me take, let beta x be equal to, we will call it as v. This implies x is equal to v by beta. Therefore, dx is equal to dv by beta, where x tends to 0, v tends to 0, and x tends to infinity, v also tends to infinity, and x to the power of alpha is equal to v to the power of alpha divided beta to the power of alpha. So we go for change of variable. Okay, now this is equal to 0, therefore this will become as beta to the power of alpha divided by gamma of alpha into 0 to infinity. See, in this x to the power of alpha is v to the power of alpha divided by beta to the power of alpha into e to the power of minus v into dx is dv by beta. So this will be equal to, so this beta to the power of alpha and this beta to the power of alpha will go off, and you will be left with beta here. Okay. This beta to the power of alpha and beta to the power of alpha will go off. So this will be equal to, see, this is, so this is equal to 1 by beta into gamma of alpha. It is 0 to infinity. It is v to the power of alpha into e to the power of minus v into d. So this is a gamma function. This is a gamma function. So this is a gamma integral. See, this is a gamma function. The value of this is, see, it is, say I write this, so this is equal to, it is 1 by beta into gamma of alpha, integral 0 to infinity, v to the power of alpha minus 1 plus 1, and it is dv, e to the power of minus v into dv. So this is equal to, so this is a gamma function. So this will be equal to, so this will be equal to, it is plus 1 minus 1. So this is a gamma function. If this is a gamma function, the value of this is alpha plus 1 gamma divided by beta into gamma of alpha, real alpha divided by beta into factorial of alpha minus 1. I will put it in this way. See, this is, okay, this you can write it as alpha minus 1, that is alpha minus 1 factorial into alpha divided by b into alpha minus 1 factorial. So these two will give me this alpha by beta. So the e of x, that is e of x is equal to alpha by beta. So what is that I have done here is, I have simply x into this, so you are getting this, then I go for change of variables as taking this beta of x as v. Because of taking a beta of x v, we have to make the subsequent changes here. When you make the subsequent changes, you finally get into 1 by 1 cancellation of everything. You get 1 by beta into gamma of alpha into v to the power of alpha into e to the power of minus v into dv. But this is nothing but your gamma of alpha plus 1. This is gamma of alpha plus 1 divided by beta into gamma of alpha. But gamma of alpha plus 1 is alpha factorial, whereas gamma of alpha is alpha minus 1 factorial. This is nothing but your alpha minus 1 factorial into alpha divided by beta into alpha minus 1 factorial. So these two will get cancelled, giving you alpha plus beta. So our mean is alpha by beta. So what is that we get here? So mean e of x is equal to mean is equal to alpha by beta. If where x is the gamma form, where x follows gamma distribution. Now let us do the variance of it. See, what is the variance of it? See, variance is equal to e of x squared minus e of x whole square. Now, e of x squared is equal to 0 to infinity x squared into beta to the power of alpha divided by gamma of alpha into x to the power of alpha minus 1 into e to the power of minus bx into dx. Now this is equal to, this is beta to the power of alpha divided by gamma of alpha. This is gamma of alpha into 0 to infinity, it is x to the power of square means is alpha plus 1 into e to the power of minus bx into dx. See, if you apply the same results, let beta of x is equal to u, x is equal to u by beta, and dx is equal to du by beta. So this will come as, see, this is, so this will be nothing but, see here, beta to the power of alpha gamma of alpha into 0 to infinity. This limit will remain the same. See, gamma of alpha plus 1 is nothing but what? U to the power of alpha plus 1 divided by b, see, b to the power of alpha plus 1 into du by beta, e to the power of minus u into du by beta. So this is nothing but your b to the power of alpha gamma of alpha, take this outside, so you get b to the power of alpha plus 1. It's b to the power of alpha plus 1. Here you get, so this b to the power of alpha plus 2 you get. B to the power of alpha plus 2 into, within bracket, this is integral of 0 to infinity u to the power of alpha plus 1 into e to the power of minus u into du. So this is nothing but, so this means you get this as gamma of alpha into beta square into, you can write this as 0 to infinity u to the power of, you can write this as alpha plus 2 minus 1 into e to the power of minus u into u. This is nothing but our gamma function, gamma of alpha plus 2. It is gamma of alpha plus 2. So this is equal to, it is 1 by gamma of alpha into b square into, this is gamma of alpha plus 2. So this is nothing as 1 factorial, and this is alpha plus 1 factorial into 1 by b square. This is 1 by b square. But this is nothing but our alpha minus 1 factorial into alpha plus 1 divided by beta squared into alpha minus 1 factorial. So these two will go off, giving you alpha by alpha into alpha plus 1 divided by beta squared. So that is e of x squared is equal to alpha into alpha plus 1 divided by beta squared. Now therefore sigma of x squared will be, e of x squared is alpha into alpha plus 1 divided by beta squared. E of x is equal to alpha, so this is alpha squared by beta squared, that is alpha squared by beta squared plus alpha by beta squared minus alpha squared beta squared. These two goes off, giving you alpha by beta squared. So sigma f squared is equal to alpha by b squared. This is our variance. So we have got the, say, I write it here. Therefore this is equal to variance of x. So this is what we did. So here what I have done is I have used the same method of doing the integration. Instead of this, I have the x squared. I find e of x squared, the second moment. Then I find the value of second moment as alpha into alpha plus 1 divided by beta squared. Then using the formula sigma of x squared, variance is equal to e of x squared minus e of x whole squared. I substitute the values and simplify and get the values to be what? The variance is equal to alpha divided by beta squared. So we have, having found this, we can solve. Now let me finish the second part of it. See, we have found this. See, what is gamma distribution, and I am able to derive the mean and the variance of it. Now let me answer the second question one by one. See, what is that he has asked? What is the question asked? Suppose the lifetime. See the lifetime. See, the lifetime of a battery means how long the battery works. That is the question. If a battery works, it has been found that the lifetime in hours, in number of hours of a certain type of battery follows gamma distribution. That means it follows the gamma distribution. The lifetime of it follows the gamma distribution. The lifetime of the battery, it follows the gamma distribution with the parameters alpha is equal to 3, which is nothing but our state parameter, and beta is equal to 0.5. Now we have to find what is the variance, how long, on an average, how long a battery will last long. We have to give it in hours. And what is the variance? The deviation from the mean is called the standard deviation. So how much, the maximum and the minimum, how far the life can change. That is more than the mean and less than the mean. That is nothing but our standard deviation. Now the question what is asked is, you are given that the life of the battery follows a gamma distribution. If it follows a gamma distribution, we know that the standard deviation, that is the PDF. The PDF is beta to the power of alpha divided by gamma of alpha, x to the power of alpha minus 1, e to the power of minus beta alpha, beta x is greater than 0, and your beta is greater than 0, alpha is greater than 0. Now you see that it follows this. Now we are asked to find what is the average hours of the life period of a battery. We know that E of x is equal to alpha by beta. What is alpha? Alpha is equal to 3. Alpha is equal to 3. Beta is equal to 0.5. So what is it you get? It is 3 by 0.5. That is equal to 6 by 5. That is equal to 6 hours. So what is that? The average life of a battery is 6 hours. And how much can it deviate, or the variance of it is given by sigma of x squared is equal to alpha by beta squared, that is equal to 3 by 0.5 whole square, 3 by 0.25. 5 into 0.5 into 0.5 is 0.25, that is 300 divided by 12, 25, that is equal to 12. So this is what is up, but therefore sigma of x standard deviation is equal to square root of 12. It may come to say square root of 12 means 3 point something. That means it may vary from the mean to this extent of square root of 12 on either it will be more or it will be less. So that is the meaning of saying that it is the standard deviation. So we are able to get this one. Now how to find answer the last question? What is the probability that the battery lasts for more than 4 hours? So this is our answer, 12 hours. So there see mean of x is equal to 6 and variance is equal to 12 hours. Now let us try to answer the next question. Let us try to answer the next question. Now what is given here? See, to find probability of x. X is the lifetime of the, here x is a random variable which denotes the lifetime of the battery, which is the lifetime of the battery. Now here we are asked to find what is the mean, see what is the probability that the battery lasts less than 4 hours. That means what? It can be less than or equal to, it can be less than 4 hours, that is less than. That means, see, x is greater than 0, the lifetime here it refers to 0. That is 0 hours to 4 hours. It can be, the life can be, it can be 0 to 4 hours, less than 4 hours. But this is nothing but what? We know that P of x less than 4 is equal to, it is 0 to 4, it is beta to the power of alpha divided by gamma of alpha into x to the power of alpha minus 1 into e to the power of minus beta x into dx. So this is nothing but what? Your beta to the power of alpha. What is our beta here now? Beta is 0.5. Beta is 0.5. 0.5 whole to the power of, say alpha is equal to 3. Say alpha is equal to 3 and beta is equal to 0.5 divided by gamma of alpha is gamma of 3 into, say I will take that outside, it is 0 to 4 into x to the power of alpha. Alpha is 3 minus 1 is 2 into e to the power of minus 0.5 of x dx. So we have to evaluate this integral. This integral is very simple. I will write the how to evaluate this. I will write and I will give you the final answer. This is nothing but 0.5 to the power of 3 divided by gamma of 3, and it is nothing but, see, the integral of this will be x squared into e to the power of minus 0.5 of x divided by minus 0.5 . It is 0 to 4 minus, I am using Benval's method of integration. Differentiation of this is 2x divided by minus 0.5. Then the integration of this e to the power of minus, that is integration of that is e to the power of minus 0.5 of x divided by minus 0.5. This must be 0 to 4. Then plus differentiation of 2x is 2 divided by minus 0.5. 1 divided by this minus 0.5 is there. Then integration of this is e to the power of minus 0.5 of x divided by minus 0.5. This must be raised to 0 to 4. So you see that this will be, say when you apply this for this 0 second, the second limit will be 0. See? Here when you apply the first limit and if you do the simplification, the probability of a battery to work for less than 4 hours is equal to 0.2550. So this is the answer. So this is how we do this. Here this simplification and all you have to do. Here you see that what I have done here is that, see there are another method you can take this 1 less x less than 4 means it is 1 minus x greater than or equal to 4 means 1.5 to infinity you can take, and you can do in that way also. Here you see that I have straight away applied this and I got the answer. You have to take, that is you have to be careful, you have to do carefully to evaluate, get the values of all these things. If you simplify this, you will get 0.2550. So that means the probability of a battery to last less than 4 hours will be 0.2550 chances. Okay, let's see more problems in the coming days. Thank you.